Hey everyone, welcome back to my channel. So today we are going to learn about the topic called population and sample data. So before beginning with this topic, we should know that why we are studying this topic. So for example, you are given a task to figure out the average salary of all the people in your country. Okay, would you able to do that? So that is impossible and impractical. So in that case, sample data comes into help. So we will study further in this chapter. Okay, how it help us. Now in this chapter we are going to study about the core concepts, definitions, practical applications along with the real world example. Now we are going to study about the fundamental challenge in the data collection. We will study with the help of one example. So suppose you are a data scientist in a large e-commerce company which has 50 million customers worldwide, and your manager asks you to find out the average customer satisfaction score to improve the services. So the big question is, would you able to do that? Would you able to contact 50 million customers and gather the customer satisfaction score? The answer is no. That is impossible and impractical. So we will we will check that why we can't study everyone. Okay. So the first point is time constraint. So for example, suppose you are contacting every customers. Okay. So total there are 50 million customers. So it might take a long time, like year or more. Okay. And in that case, the data might get outdated. Why outdated? Because for example, the perspective of the customers might have changed about your services. Okay, so we need a fresh data. The second is the financial burden. So in order to collect this feedback from every customer, then in that case you have to roll out the survey. Okay, and that will cost you. So that's why that is a financial burden. The second is logistical impossibility. So for example, some of the customers, okay, they might have changed their contact info, okay, or they are unreachable, or they have left the platform. Okay, so that is a logistical impossibility. And the fourth point is the practical limitations. So for example, your manager asks you to collect the data quickly because they have to make a smart business decisions, but in your case it will take long time. Okay, so that is a practical limitations. That's why you cannot contact all 50 million customers. So now we are going to study about the two different terminology, that is parameter and statistics. Okay, so the parameter refers to generally population, while statistic refers to the sample data. So in case of population, for example, if you want to figure out the average salary of all the people in your country, so you don't know the exact value. Okay, the value is unknown to you. But in case of sample data, if you choose only, for example, 5,000 random people, okay, to figure out the average salary, in that case the value is known to you and you can easily perform the calculation. Okay, and in case of parameter, generally it is rarely calculated. Okay, no calculation is performed on this parameter. Now we will study the practical example. So for example, there is a scenario. Okay, so you have to find the average income in the city, and the city contains 2 million working adults. Okay, so in that case the population refers to the 2 million working adults in the city, and the parameter is you need to figure out the true average salary of all those 2 millions people. Okay, 2 million people in your city. So you don't know that salary. Okay, that is unknown to you, that parameter. But for example, you choose only 1,000 random people. Okay, 1,000 working adults random. You choose 1,000 randomly selected adults. Okay, so in that case the statistic will be the average salary of all those 1,000 random people. Okay, and the last term is called the inference. So what is inference? So you have the population data, you have the sample data. Now based on the sample data you have to draw the conclusions about the population data. Okay, so that is called the inference means you have to draw the conclusion. Okay, you are drawing the conclusion about the population data using the sample data. So now we are going to study about the types of sampling methods. So these sampling methods are used in the different situations, and we will be studying the most common used methods. So the first is the simple random sampling. Here I will be reading the text and then I will explain you. So every member of the population has an equal chance of being selected. So for example, you have a hat, and that hat contains the name slip of 100 peoples, and you have to select the 10 names. Okay, so you will be picking the slips randomly. In that case, those 100 peoples have equal chance of being selected. So for example, you have 1,000 students and you assign each students a number that is 1 to 1,000. Okay, and now we are using the random number generator function from any coding language, that is JavaScript or Python. Okay, and you have to select only the 100 students. In that case, all students have equal chance of being selected because there is no bias. Okay, and when this strategy is used, for example, you have the population which is homogeneous, means it has the similar characteristics, and you have the complete list of all members. In that case, you will be using the simple random sampling. And what are the advantages? So as I have tell you earlier, so it is a completely fair, and there is no bias, there is no nepotism and favoritism here, and everyone has equal chance of being selected, and it is easy to understand. Now it also has the drawbacks. So the drawbacks are, you need a complete list of all people. Okay, so this means when you have a smaller groups, okay, when you are surveying the smaller population, then it is okay. But when you have to survey the larger population, then you may not get the complete list of all members. Then in that case, this sampling simple random sampling strategy fails. Okay, the second point is, smaller group might get missed by chance. So this means, for example, you are surveying a school having the 1,000 students, and in that school there are 30% girls and 70% boys, and you use the random number generator to pick the 100 students. In that case, you might miss the number of girls, okay, in your sampling. So you may not cover the equal, like equal selection, means all the girls may not get the equal chance of being selected, because if you see the ratio, there are 70% boys and 30% girls. So girls might get missed in the samples. Okay, and this strategy is time consuming when if your population is very large. Now coming to stratified random sampling. So this sampling strategy is used, okay, when you have the population divided into groups, okay, and you know the characteristics, okay, that group is based on the characteristics. So then in that case, you will divide the groups based on the characteristics, and you will pick the random people from each group. So I will take the previous example. Okay, that was a drawback of the simple random sample strategy sampling. Okay, so suppose for example, a college has a 60% boys and 40% girls. So you want 100 students to survey. Okay, so you what you will do in this sampling strategies, you will be randomly picking the 60 boys, okay, from the 60% boys group, and 40 girls, randomly picking the 40 girls from the 40% of girls group. Okay, so that you can maintain the ratio. So when this sampling strategy is used, this is used when you have the population with different kind of characteristics. Means there has population as a distinct subgroups. Okay, and you have to present it proportionally. Okay, so what are the advantages here? So in this case, it will guarantee that all the groups are included, even if it is a smaller group. So in the previous sampling strategy, that is simple random sampling, I have told you that smaller group might get missed. Okay, but in this case, it will guarantee that all the important groups are included, and it is more accurate than simple random sampling. Then what are the drawbacks here? So in this case, you must know about the population characteristics before you do the apply this sampling technique. Okay. And if the population is very large, then you have to do more work. You have to divide them into the different groups, and it might be more complex to organize. Now coming to the systematic sampling. So what it is, like, think of it like you are taking every 10th person in the line. Like for example, you are counting 1 2 3, and when you reach the 10, you pick that person and you count, you start the counting again. Okay, so you keep on repeating. So you will be picking those 10th person, 10th persons in your sample. Okay, so let me explain you an example. So for example, you are standing at a mall exit and you have to survey 100 people, okay, out of 1,000 visitors coming to the mall. So what you will do is you will survey every 10th person who exits the mall. Okay, so in that case, you will get the 100 survey for the 100 people. Let me tell you another example. For example, a bakery makes 1,000 cakes daily and you want to check 50 cakes for the quality. In that case, you will be picking every 20th cake. Okay, so in that case, you can check 50 cakes out of 1,000 cakes. And when to use it? When you have the data, okay, arrange in the order. Okay, like for example, people are in the line, or the products on the conveyor belt, okay, or the files in the alphabetical order. So here order matters. And what are the advantages here? Like, it is very easy to do the counting. It is not like you are picking the random numbers, and there is no need for computer or the random number generator for this. But there is a drawback here. So you might miss a hidden pattern. Okay, so for example, there is a conveyor belt, and which is like the whole machine is manufacturing the bottles. Okay, and on the conveyor belt you will be picking the 20th bottle. Okay, but there is a issue here with the machine. So for example, if the machine is breaking the 20th bottle, okay, so when you collect the samples of those 20th bottle, then in that case, you will see that you will only get the bad bottles. So you will be missing the hidden pattern here, because the rest of the bottle are manufactured correctly without any flaws. Okay, so in this case you can miss the hidden pattern in this sampling technique, and it is not truly random. Okay, so that is a drawback here. Now coming to the cluster sampling. So what is a cluster sampling? Imagine you want to survey students across the 100 school in the state. Okay, so instead of picking the random student from all the schools, it will be expensive. Okay, you have to visit every 100, you have to visit all 100 schools in that case. So in order to avoid that, you will randomly pick the 10 schools and survey every two students from those 10 schools. So you can consider each school as a cluster. Okay, let me give you another example. Okay, so for example, you have 100 box of chocolates. Okay, so in order to survey those 100 box, what you will do, instead of opening all the 100 boxes and picking few random chocolates from each box, you will randomly pick the 5 box and taste all the chocolates in those 5 box. Okay, so this is called a cluster sampling. Let me give you another example. So for example, you want to survey 1,000 students from a city. Okay, with 50 schools. Okay, so in the normal way, you will visit all the 50 schools and you will pick 20 random students from each school. Okay, so that will be 50 trips. It will take a lot of time for you, and the cost will be more. Okay, but in the cluster way, you will only pick the 10 schools and survey all the 100 students in each school. Okay, so there will be only 10 trips to the school. It will save your time. Okay, so now coming to when to use this sampling technique. Okay, so when your population is naturally divided into groups, and those groups are in different geographical areas, okay, spread out in the different places, so in that case you will apply the cluster sampling strategy. But this sampling technique also have pros and cons. Okay, so let me tell you. So the the first point as a advantage is it will saves your money and time. Okay, and it will be good for like you have a very large geographical areas and it will be easy to organize. But the drawback here is it is very less accurate. Okay, so for example, if your clusters are very different from each other, for example, if you only pick the schools from the urban areas and you miss the schools from the rural areas, in that case you will not get the accurate result. Okay, when you collect the data only from the schools from the urban areas, in that case, and when you feed that data to the machine learning model, then your model will not predict accurately. There will be issue with your model. Okay, so here the second point is same. If one cluster is weird, then it will affect your whole result. Now I will quickly repeat what we have studied so far. So, for example, what is a simple random? Okay, so in the simple random, we have studied that each and every person gets equal chance of being selected. Then we have the stratified sampling. Okay, so in this sampling technique, we know about the characteristics and the groups. Okay, and we in order to maintain the ratio. Okay, for example, like 60% boys and 40% girls. Okay, so in order to maintain the ratio, we divide the data into the different groups and we pick the random person from that group. Okay, so that is nothing but a stratified sampling. Now coming to the systematic sampling. Okay, so this sampling is used when you have the data in order. Okay, that is maybe student are arranged in alphabetical order. Okay, so or for example, you have the files in the computer that are arranged alphabetically, then in that case you will use the systematic sampling. Now, coming to clusters, okay, a cluster sampling is used like when you have the data, okay, spread in the large geographical areas. So instead of visiting all the places, you choose, okay, the clusters in such a way that like you will visit only those clusters and survey every person in those clusters. Okay, so that is nothing but a cluster sampling.